Hello everyone. Good afternoon. Welcome to session 6. Sixth chairman of the session, Professor Dr. Neslihan Doğan-Sağlamtimur. I want to introduce. Neslihan Doğan-Sağlamtimur works at Professor Dr. Etnide Ömer Halis Demir University Environment Engineering Department. Doğan-Sağlamtimur received her BSc in Environmental Engineering 1994 from Fırat University, Elazığ, Turkey. Her MSc in Environmental Engineering 1998 from Mersin University, Mersin, Turkey, and her PhD in Chemical Oceanography in 2007 from Middle East Technological University, Mersin in Turkey. Doğan-Sağlamtimur is member of Chamber Environmental Engineering and the International Society, Exoexology and Environmental Safety and its Radical Session. Yes, dear Sağlamtimur, it's yours.
Thank you. Yes, in this section, we mention about water and wastewater management strategies and topics. This is section 6. Yes, first of all, I would like to announce you Reza Dekhani Bidgoli for the title of Effect of Wastewater Irrigation on Phenolic Compounds and Antioxidant Activity of Echium, amoenum, Fisch. He works as an assistant professor at University of Kashan, Iran. Reza received his BS in Environmental Sciences in 2002 from the University of Tehran, Iran, and his PhD in medical plants in 2012 from Agricultural University of Georgian, Iran. He's a faculty member of the Department of Rangeland and Watershed Management at University of Kashan, Iran. You may be contacted him in his email address seen in his paper.
Dear Neslihan, absent Bidgoli, I think. We should next other presenter.
Yes,
I think
I continue to announce you second presenter. She is Seray Zoza Tarhan. The title of her presentation is Botyrococcus Braunii Cultivation in the wet oxidation liquid from the hydrothermal carbonization of orange pomace. Seray Zoza Tarhan works at Abdullah Gül University Bioengineering Department as a research assistant. She graduated from Yeditepe University and she finished a Master of Science study on utilization of hydrothermal carbonization water for microalgae growth in Yıldız Technical University at Bioengineering Department in 220. She's interested in microalgae, microalgal growth, biomaterials, and tissue engineering. She may be contacted at zoraseray@gmail.com. Yes.
Thank you very much, hocam.
Thanks.
Can you see my share screen?
Yes.
Okay. I'm starting. Hello everyone, I'm Seray Zoza Tarhan from Abdullah Gül University, and today I want to talk about the different perspective for both maize management and also microalgal cultivation. That is Botyrococcus braunii cultivation in the wet oxidation liquid from the hydrothermal carbonization of orange pomace. And actually, this study was a collaborative study including National Center for Scientific Research and also Yıldız Technical University Bioengineering Department. In the first stage, I want to talk about firstly the food wastage problem in the world, and then I want to talk about Turkey. As you know, management of food waste is a huge problem for us and also for the environment, and this problem can lead to both food scarcities and also environmental issues. While some countries produce an excess amount of food waste, and also you know that this food waste, landfill food waste, leads to releasing of unnecessary greenhouse gases such as carbon dioxide and also methane, and also this cases leads to global warming. And other countries at the same time cannot achieve sufficient food supply, clean water, and also clean net for their activities. And actually due to that, management of food waste is important for us. And in here, I want to talk about the reality. According to Food and Agriculture Organization of the United Nations, approximately 1/3 of all food that is produced for our consumption in the world is wasted. Actually, this is a huge number for us and also for the world. And this means that approximately 1.3 billion tons of food waste are lost due to unconscious consumption of us and also non-recycling. In this figure, and you can see I'm so sorry. In this figure, and you can see the different contributors and to the annual global food waste. And in the first line, you can see the fruits, vegetables, and root crops as a first contributor to the food waste. And actually, due to that, in this study, we want to focus on the fruit and vegetable type as the orange pomace. And in here, and I want to talk about the food waste iceberg because actually I want to talk about something in here. In the upper part, and you can see only some economic problems or also something about the money. And every day we are talking about the money and economic things. However, in the bottom part, we have a huge problem compared to economy. For example, if we cannot manage the food waste in Turkey or in the world, and we can lose our clear forests, and we can face with increase in the food prices, increase water scarcity, arid plant, loss of biodiversity, such as different type of animals, plants, and different living creatures. And also, this is what is the main problem? Actually, disease and greenhouse gas emissions can be increased due to that. And as a result of that, we can face with climate change damage. And now I want to talk about the food waste problem in Turkey, actually. According to reports, agricultural production is contributing with 8.53 to the Turkish gross domestic product. And as you know, we are the main producers also for the world. And about the production and exportation of vegetables, nuts, and fruits. And actually, due to that, the management of the food waste derived from these products is important for us. And however, and also for today, we don't have any effective management treatments. And still, we are using different methods, burial, burning, or disposal in rivers and lakes directly. And actually, these are not real solution to solve this problem. And in the last figure, in the bottom part, and you can see the food production and loss from the agricultural production in Turkey. Actually, I want to show you from here, and most part of the products, food waste, derived from the agricultural things, agricultural industrial things, and also we have a lot of food waste in here, and actually due to that we want to focus this part in our study. And now I want to talk about the importance of orange pomace waste in Turkey, because in our study we use orange pomace waste in hydrothermal carbonization. Turkish Statistical Institute report that Turkey ranks as a 9th citrus producer in the world. And actually we know that approximately 3.6 million tons of citrus are produced in Turkey. And also we want to study about the orange pomace, because orange is among the most important ones with 1.78 million tons of production capacity. Yes, actually this is a good thing for us, for the exportation and economy. However, as a result of that, we are obtaining considerable amount of side products such as citrus pomace, and this pomace actually includes half of the citrus mass, and also known as citrus waste, orange waste for the orange case. And it's estimated that 115.5 million tons of waste are derived from the citrus production in the worldwide. And now I want to talk about the main component of our study, hydrothermal carbonization. Actually, this is a specific process providing thermochemical conversion and transformation of wet biomass to the dry hydrochar and also different chemicals in process water. And for this process, we don't need any pre-drying step. And this process is conducted between 180 and 250 centigrade degree under saturated pressure. And as a result of that, as a result of this process, we can obtain two main products, and solid phase, that is called as hydrochar, and also liquid phase, including different type of chemicals. And in here, actually, we know that hydrochar is utilized in different areas. And also, for example, it can be used in soil enhancement application, remediation of wastewater pollution, and renewable energy. However, in the aspect of process water, we have some problems because, as I previously mentioned, this process water have different type of metabolites, for example, phenols, furfuryls, and different derivatives. And due to that, we cannot release this process water to the environment directly because this is toxic for us and also for the environment. And now I want to give some information about the wet oxidation briefly. And also wet oxidation is another component of our study. It is a specific method that provides oxidation of suspended or dissolved compounds under hydrothermal condition. And in this treatment, water is used as an oxidant. And this process provides significant decrease in the total organic carbon volume. This is important for us because, as I previously mentioned, we want to reduce the total organic carbon content of the processed water because this is a toxic water for us. And also at the same time, we can increase the short chain organic acids such as acetic acid content of the AP. Also, this is good for us because we know that from the literature, acetic acid promotes mixotropic growth in algae, and in mixotropic growth condition, in algal culture, we can obtain higher growth rate and lower doubling time. And due to that, in this study, we want to use this process after the hydrothermal carbonization. And now, I want to talk about that and why we want to study with microalgae. Because we know that microalgae has specific capacity to remove nitrogen and phosphorus from wastewater. And in this study, also we have a wastewater as process water from hydrothermal carbonization. And also we know that algae are the fastest growing photosynthetic organism, and due to that, we can use this organism in our lab easily. We can cultivate this microorganism easily in shorter time. And also we know that algae can do photosynthesis with the help of sunlight. And as a result of all process, we can obtain energy-rich compounds that can be used different research area or that can be used for different applications, such as nutraceutical industries, biofuel production, and biopharmaceuticals. And what is our motivation? Actually, we aim to improve the process for the safe disposal of the hydrothermal carbonization process water. And also we want to demonstrate the effect of hydrothermal carbonization process water treated with wet oxidation on algal growth directly. And for these purposes, we performed hydrothermal carbonization using orange pomace. And also, we treated this hydrothermal carbonization process water with wet oxidation method. And then we did some analysis, I will talk about that. And then we used different concentration of this wet oxidation liquid for algal growth. We observed the algal growth with the help of growth kinetics data. And now in here, I want to summarize our method. In the first stage, actually in here, I want to mention that the some part of this study was conducted in France by Professor Dr. Özçimen. In the first line, we have orange, and also in the second line, we have orange pomace as a real base. And also, this orange pomace was treated with hydrothermal carbonization process in 300 milliliter batch reactor at 200 centigrade degree for 1 hour. And after that, as I previously mentioned in the introduction part, we obtained two phases: process water, liquid phase, and also hydrochar. Actually, we know that this process water have some toxic effects on the environment, and due to that, we focus on. And after that, after the treatment of hydrothermal carbonization, we treated our aqueous phase with wet oxidation at 200 centigrade degree for 30 minutes with 2 milliliter hydrogen peroxide as a catalyst. And then actually we did some analysis for the aqueous phase and also for the wet oxidation liquids. And then we decided to different concentration. We use 4 different concentration for algal growth as a direct medium. And then for 40 days, we observed the algal growth behavior. We use it growth kinetics data and also optical density. Now, I want to talk about our results. Firstly, I want to talk about characterization of wet oxidation liquid. Actually, in the first line, you can see the characterization of hydrothermal carbonization process water. Actually, these values were published. And due to that, in here, I used these values for the comparison. And you can see the pH, acidity, conductivity, total organic carbon, and etc. Different biochemical different biochemical things in here for the hydrothermal carbonization process water and also wet oxidation liquid. Actually, total organic carbon concentration and acetic acid concentration are the most important ones for us because, as I mentioned previously, decrease in the total organic carbon is important for us, for environment and also for the algal growth. And also acetic acid is important because it promotes the mixotropic growth, it promotes the higher growth rate and etc. And due to that actually, we want to see the differences between the wet oxidation liquid and also hydrothermal carbonization process water on algal growth. And now in here, I want to talk about the growth behavior of the algae in hydrothermal carbonization aqueous phase treated with wet oxidation. Also in here we have published results. And firstly, I want to analyze the first line. Actually in here we have BG11 as a control media, and also we have different concentration of wet oxidation. As you can see from here easily, actually we obtained the higher growth rates in the higher concentration, lower dilution ratio for the wet oxidation liquid in the first stage. However, also we know that we obtained the comparable results with the control medium. And also because of that, and this result is important for us. And in the second line, we can use the different values, including growth rate and also doubling time. Again, actually, we observed the highest growth rate in 50x concentration of hydrothermal carbonization process water. However, as you can see clearly from here, we obtained the high results with the help of wet oxidation liquids. And in here, actually, I want to summarize everything for you. In this study, we use Braunii and Cultivation in the wet oxidation liquids obtained from the hydrothermal carbonization treatment of orange Pomace. And also we observed that we obtained higher growth rates and also lower doubling times, and that are comparable with control media. And also we observed the shorter adaptation time, and also this is important for us. And according to growth data of microalgae, we can say that we obtained the specific growth trend dependent on the concentration of the wet oxidation liquid. And as a result of that growth kinetic analysis, we can say that this algae can be cultivated efficiently in higher concentration of wet oxidation liquid. And also we can say that actually we obtained the cost-free media for our algal cultivation and our laboratory. And also these results shows that with the help of this method, this design, the process water obtained from the hydrothermal carbonization treated by wet oxidation can be used for the growth of microalgae efficiently, and at the same time, this system provides a safe disposal way for the hydrothermal carbonization process water. Actually, these are my references. Thank you for your listening. If you have any question, you can ask me or you can contact with me.
Thank you, Seray Zora Tarhan. for your presentation. Is there any question or comments? Yes, thanks. I think no comments and questions. Yes. In the next presentation, I would like to announce you Çiner for presenting circular economy for water. Yes, Çiner works as a professor at Nida Ömer Harisdemir University, Environmental Engineering Department, and me is also another author of this presentation. Çiner received her Bachelor of Science, Master of Science, and PhD in Environmental Engineering departments, all of them from 9 Eylül University, Cumhuriyet University, and Istanbul Technical University, respectively. She's interested in drinking water, unit operations in water treatment, water and wastewater management, wastewater treatment and industrial waste solutions. Let's listen her.
Thank you very much, Professor Doğan-Sağlamtimur. Good afternoon, everybody. It's the first time attending the online symposium. This is the big tecrübe diyeceğim ama şu anda İngilizce yes, I shared my presentation firstly. Okay. Yes. Evet. I talk about today. I talk about circular economy for water, as you say to Neslihan Doğan-Sağlamtimur. Firstly, I would like to begin importance of the water. As you know, water is fundamental substances for all organisms. And one of the most common problems affecting people is an inadequate water access to clean water and sanitation. Water scarcity, water security concerns, and requirements to remove nutrients and emerging contaminants from effluent discharge to surface water have driven water reuse as an alternate water supply in some parts of the world. And recycling and reuse are central to circular economy approach because of the water scarcity and the other problems. This study gives some details about definition and concept of circular economy for water, addressing its principles, opportunities, applications to water system management. In this slide, in this section, I would like to talk about scope of circular economy for water. First, I would like to define circular economy. The term of circular economy refers to an economy's ability to grow while resource use is declining, the decoupling of economic growth from resource consumption and pollution. The circular economy can cover a broad scope, finding some researchers have focused on different areas such as industrial applications, natural resources and services, practice and policies. The circular economy includes products, infrastructure, equipment and services and applies to every industry sector. It includes technical and biological resources.
Professor Çiner, Is it possible to full screen to your presentation? Is it possible full screen?
Oh,
Please press full screen.
Yes.
Thanks.
In this part, information and principles about circular economy for water. The circular economy is a practical alternative to the current linear economic model, and a circular economy is an economic system because of the eliminating waste and the substantial use of sustainable use of resources. And circular systems employ reuse, sharing, repair, refurbishment, and remanufacturing and recycling to create a closed loop system, minimizing the use of resource inputs and minimizing the creation of waste, pollution, and carbon emissions. And this new section, you can find information and principles about circular economy for water. I think all of you know very well that water is used and offers value in a number of different ways. These dimensions of water use can be grouped into three themes of such as service, energy, and carrier. And conventional wastewater treatment usually ends with secondary treatment. For water reuse, tertiary treatment is needed to provide additional removal of contaminants such as microbial pathogens, nutrients, and advanced treatment processes are employed when wastewater is to be reclaimed for reuse. Some quality requirements. And in this part, there are three pictures. On the top of picture, you can see a circular economy loop starting return and make, and the last one is use. These three departments are form a loop. And the other, in the second picture, you can see famous 5R. For circular economy, refuse, from refuse, reform, reduce, reuse, and recycle. And the third figure on the left side, you can see another circular economic concept starting from raw material extraction, product design, and production and remanufacturing and communities and waste management. And this slide has a figure. These figures show a holistic approach for circular economy. You can see political and decisional factors. These are funding available regulations, existing plans and policies, and reuse alternatives, resource recovery. And the other factors, second factors named economic and social factors, treatment cost, monitoring cost, and social and economic context include these factors. And third factors are technological factors. These are centralized systems, raw wastewater quantity and quality, existing wastewater treatment plant, etc. And environmental factors are fourth factors, some of quality of receiving water, weather and climate change, desertification and environmental impacts, energy consumption, greenhouse gas emission, like that. And this slide has a table. In this table, you can see circular economy principles versus water system management. These are three principles of circular economy. First principle is design out waste externalities. For these, we optimize the amount of energy, minerals, and chemicals used in operation of water systems. Second, optimize consumptive use of water. And third one is use measures or solutions which deliver the same outcome without using water. Second principles, keep resources in use. We optimize resource yields, optimize energy and resource extraction from water system, and optimize value generated in the interface of water system. And the last one, principle 3, is regenerate natural capital. We maximize environmental flows, preserve and enhance the natural capital, and ensure minimal disruption to natural water systems. In this section, I would like to mention about opportunities of circular economy for water. The opportunity with circular economy for water is to better align the human water cycle with the natural water cycle through 5 parameters: avoid use, reduce use, reuse, recycle, and replenish. And in this slide, for discuss and conclude this study, I would like to mention about something. First of all, fundamental access to safe water and sanitation systems for all communities, especially in crisis situations. The human right to water and sanitation is based on the following criteria, 6 criteria: availability, quality, safety, acceptability, accessibility, and affordability. The assessment of water consumption under crisis or pandemic situations like COVID-19 is important for decision makers to define actions to ensure the availability of water for the population and for the maintenance of essential services. And with the increasing momentum in the transition towards a circular economy and the worsening impacts of the global water crisis, we see an opportunity to combine efforts to achieve mutual benefit. A truly circular economy has to focus on retaining end-of-life products, components, and putting them back into value chain. Research and innovation are needed to redesign the value chains to close material. End-of-pipe technologies, as you know, nowadays end-of-pipe technologies are not enough in environmental engineering. In a circular economy, research and innovation for manufacturing, reusing, and recycling can make fundamental steps towards waste minimization and efficient and sustainable use of resources. And as a result, by applying circular economy for water, the people gain many advantages. And thank you for listening. And thank you very much. I'm finishing the presentation now.
Thank you, Professor Dr. Çiner. Any comments or questions? I realized that Dr. Ajay Singh wrote everyone that could you please highlight the environmental impact of wastewater reuse? Professor Çiner, could you answer this question or me?
I couldn't understand the question.
Yes.
If you want to answer, you can answer. Okay.
Yes, please show us second or third slide.
Third.
No, second slide. Second. Yes. Dr. Singh, water reuse is important because water scarcity, because of water scarcity, water security concerns requirements to remove nutrients and emerging contaminants. These four factors are important for reusing, for deciding to reuse water. Thank you. In the former two presentation, Seray Zora Tarhan mentioned about algae and cultivation of microorganism in orange pomace waste, and her team designed an experimental study for using algae cultivation in this waste. In the second presentation, Çiner mentioned about circular economy concept, like definition using opportunities principles, and in the third presentation, another question. Yes, could you please highlight the environmental impact of wastewater reuse? Environmental impact of wastewater reuse. Yes. If you reuse wastewater, this question is from Dr. Ajay Singh also. Wastewater reuse. I'm the second author of this presentation. Because of this, I would like to answer these questions. Wastewater reuse. If you clean this wastewater effectively by using a tertiary treatment, Professor Dr. Çiner mentioned about this. In classical systems, we use secondary treatment for cleaning, for treating wastewater. In the system, circular economy system, we prefer tertiary treatment. Tertiary treatment and advanced treatment is very effective systems, and you can clean, you can treat wastewater effectively. Therefore, you obtain clean water for circling in the system. Because of this, you obtain many advantages. You gain many advantages of many environmental advantages, and decrease environmental impact of wastewater also. Thank you. And I would like to, after mentioning the former two presentations, I would like to continue from third presentation. The title of this presentation is Influence of Current Environmental Pressures on Ecosystem of Dil Stream Basin. Meltem Yağcıoğlu will present this paper. She works as a research assistant at Gebze Technical University, Institute of Earth and Marine Sciences. Yağcıoğlu received her Bachelor of Science in Environmental Engineering in 2012 from Koçer University, Turkey, and she is still Master of Science student on Earth and Marine Sciences at Gebze Technical University, Institute of Marine Sciences. You can contact her, Meltem Yağcıoğlu, at gtu.edu.tr.
Yes. Hello, everyone. Hold on. Can you see my presentation?
Yes, we can see.
Yes, I can.
Yes. Hi everyone again. I will talk about influence of current environmental pressures on ecosystem of Dil Stream Basin. First of all, I will tell you about my field of study. Then I will continue as analysis, observations, and results respectively. In the water ecosystem, stream systems balance the basin hydrology. They are the natural drainage basin that collects the surface water resources, the drainage waters, and biological reserve areas. These stream systems have evolved over hundreds or thousands of years under prevailing hydrological conditions. Changing the natural drainage basin with the effect of industrialization, agriculture, or urbanization causes changes in the movement and storage of water. This stream basin, which has strategic importance in many aspects, has been divided into 7 sub-basins for the first time with this study. Firstly, surface water chemistry and then land data were studied in detail. Geomorphological conditions, land use, topographical changes, and the effects of these changes have been examined. Geographical information systems were used for analysis and evaluation methods. At the beginning of industrialization in the 1960s, Turkey's largest company settled in the Gebze and Dilovası districts of Kocaeli. With the further growth of industrialization in the 1980s, the region between Dilovası and Çayırova has become a region where both residential and industrial facilities are intertwined. Industrial facilities, settlements, quarries, small-scale agricultural and livestock lands, wastewater treatment facilities, and various wastes and wastewater entering the basin from these sources, especially organic substances, become a threat in the basin. Besides all these negativities, the region also hosts an important historical bridge. It's known that this bridge, which was built by Mimar Sinan in the 16th century, was used as a caravan and expedition route in the Ottoman Empire. The location map of the study area is given in figure. This stream basin has an area of 131.5 square kilometer and a dendritic drainage system. The Northern Anatolian Motorway, Anatolian Highway, and high-speed rail passes over this stream that divides the Dilovası district center into 2. 7 sub-basins were created using the soil and water assessment tool model in figure A. While creating sub-basins, industrial activities, basin poor points, the location of drinking water resources, organized industrial zones, agricultural and livestock lands, quarries, and nature parks were taken into consideration. The coordinates of the sampling points were determined by using GPX Weaver Pro, its mobile application software, and their locations are given in Figure B. Within the scope of the study, water samples were taken from 16 points determined in July in 2020. In water samples were taken in 0.5 liter polyethylene bottles in accordance with the communic on sampling and analysis methods of the water pollution control regulation. Water samples were acidified with 5 milliliter of nitric acid by filtering through a 0.45 micron filter before analysis to remove solid particles. It was kept in a closed environment at 4 centigrade degree until the analysis process. Analysis of heavy metals and other metals expected to cause pollution were performed using Perking Elmer Optima brands ISP OES. All of the heavy metal types were evaluated according to Table 4 and Table 5 included in Annex 5 of Regulation on the Amendments of the Surface Water Quality Regulation. Water quality parameters were analyzed from 16 points in the Dil Stream Basin, and results regarding the current pollution level were obtained. Aluminium, ferrous, and zinc concentration values, which have the highest values among the analyzed 17 metals, are shown in the graph. When the distribution of metals in subbasins is examined, it was determined that all subbasins exceeded the limit values given in the regulation on the amendment of the surface water quality regulation. Subbasins with the highest values in aluminium, zinc, and ferrous concentrations are Adatepe, Kocakaya, Pilitli, and Tembelova. Environmental quality standards for rivers or lakes are divided into 2 categories in Table 4 of Annex 5 of the regulation. These are annual average environmental quality standards and maximum allowable environmental quality standards. Analysis results were evaluated according to the maximum environmental quality standard. It refers to the monitoring data of any pollutants and or priority substance in case of an accident, a natural disaster, etc. The highest aluminium, ferrous, and zinc values have been measured, and D5 and D7. These high values are thought to be caused by wastewater of the metal coating facilities and leached from closed landfills. In addition to this, it's thought that the quarries in the vicinity of the sample points are also effective in the high concentrations of aluminium, ferrous, and zinc. During the field studies, dark-colored and smelly water with bubbles was observed at sample point D5 in Kocakaya subbasin. and at sample point D11 in Adatepe subbasin, it's thought that these bubbles could be generated by methane and hydrogen sulfide gas. BOD is the expression used as a measure of organic pollution. BOD analyzes results of D7, D11, D1, 3, D5, and D12 exceeded the limit values specified in the regulation. The increase in BOD concentrations decreases the dissolved oxygen values in the water and causes anaerobic conditions to occur. Uncontaminated natural waters have a BOD content of 5 milligram per liter or less. D7, D11, D1, 3, D5, and D12 BOD values are 378, 358, 128, 538 milligram per liter, respectively. COD and nitrate results have been evaluated according to the regulation on amendments of the surface water quality regulation. It's seen that these values exceed the limit values in Adatepe, Kocakaya, and Pelitli subbasins. The reason for the high values of COD, BOD, and nitrate in the samples taken from the Adatepe subbasin, Kocakaya subbasin, and Pelitli subbasin is thought to be due to industrial facilities, uncontrolled leakage discharge, agricultural areas, and old dump sites. During the field studies, the release of uncontrolled wastes after the feast of sacrifice was observed at sample point D5. This situation can be shown as the reason for the high COD and nitrate values seen in the previous graph. Land use directly affects the water quality of the basin. Land use seems to be effective in the current pollution of the stream and its surroundings. General physical changes in the Dil stream basin were understood from satellite images of 1986, 20 and 6, 20 and 20 in figures. The areas marked with yellow dashed lines show residential and industrial areas in figures. It's seen that anthropogenic factors such as rapid population growth due to migration, urban growth, industrialization increase the pressure on geomorphological conditions. In the study area, the changes in the land use, land cover classes according to the Corin system were tried to be determined over the Corin maps of 2020 and 18 in below figure A and figure B. Human activities are gradually changing the natural land cover of the earth and the use of land. Land use causes land cover change. With these maps, we can clearly see the 18-year change in land use in the study area. According to the results of Corin Corin 2000 data, the largest area of the Dil stream basin covers the mixed forest with 33.62%. According to Corin 2080 data, it's seen that the mixed forest area is 0.71%. Industrial or commercial unit areas increased from 6.03% in 2000 to 18.24% in 2018. There is a considerable decrease in forest areas and a considerable increase in industrial areas are seen on the tables. In the chemical analysis results, it has been determined that Adatepe, Kocakaya, Tembelova, and Pelitli sub-basins are much more polluted compared to Öteyüz and Denizli sub-basins, which provide limit values specified in the regulation on surface water quality. The reason for the pollution in Adatepe, Kocakaya, Tembelova, and Pelitli sub-basins is the wastewater from the organized industrial zones, closed landfill leaches, quarries, geological formations, etc. With the help of field observations, satellite images, and coordinate land use maps, the changes in the morphological conditions of the basin from the past to the present have been evaluated. During the field studies, large-scale excavations in road constructions and fillings in stream beds negatively affected the natural structure of the basin were observed. When satellite images and coordinate land use maps are evaluated, the increase in residential areas parallel to the development of the industry and a significant decrease in forest lands draw attention. This study was carried out as preliminary finding of Masters of Science thesis study entitled Determination of Physical and Chemical Characteristics of Dil Stream Drainage Area in the Gebze Technical University Institute of Earth and Marine Sciences. And thank you for listening.
Yes. Yes, I realized from chat screen, Teoman Sanalan wrote to everyone that Dil Deresi has turned out to be a BOD stock. The scale shall be rearranged to demonstrate the contamination level at all sites. Teoman Sanalan, could you ask another thing? Could you comment another topic to presenter, or is there any question or comments? Yes. Teoman Sanalan is here or not?
Yes, I am here. Can you hear me?
Yes, I'm hearing.
Yeah, sorry for interrupting, but I was just watching the presentation. I think it's a very relevant subject for environmental pollution. Dil Deresi is a hot spot, or let's say black spot, because the Dil Ovası region is highly industrialized with a lot of contamination. I dealt with Dil Ovası region in sense of industrial pollution control for several years and tried to regulate the industrial sources in sense of air pollution. And we were partially successful, but I was also insisting or let's say emphasizing the need for water quality issues, because Dil Deresi is highly contaminated, and I've witnessed that during many site visits. I don't have a critic, but I just first thanks to the presenter that it's very important subject and very relevant presentation. Just for the graphics, because of high difference of COD and also BOD, of course, levels. So the graphs, I think, doesn't show in sense of the water quality classes. So she mentioned that 5 milligrams, for example, is the indicator of non-contaminated water. It's another issue, but I think we could better see if some of the monitoring points or sampling points are above or below, because of several points that are very high in BOD. We cannot understand because the scale is, for example, the smallest, let's say, increment is 100. Do I see well, or I'm not sure? 0 to 100, huh? Could you confirm that? Yeah, I see. Yeah, 0 to 100. So I cannot understand, for example, D14, D13, D12, D2, D3, if they are above or below 5.
Can you see my presentation now?
Yes, I see it now very well.
These slides you question me. These BOD contents of 5 milligram per liter or less. You asked me these about these sentences. I couldn't understand.
Just the graph, because of this
The graph.
Yeah,
yes.
They are very high. So the graphic scale is from 0 to 600. So you mentioned that the BOD content of 5 milligrams is a threshold between polluted and, let's say, less polluted water or unpolluted water. So
yes.
I would wish to see the scale. For example, it could be logarithmic scale that we could see the other points of monitoring, if they are above or below 5. Am I more clear now?
Okay, I understand now. You asked me, I think you asked me D14, D13, D12. Yes. Their values low than 5 milligram per liter. You ask it.
Yes.
Yes, these are lower. These are lower than 5 milligram per liter, but I didn't say it this presentation, but I can say yes, their values are lower than 5 milligram per liter.
Thank you. And thank you for this study.
Sorry.
Thank you for the study. This is very important study, I think.
Thank you very much.
Neslihan hocam, sesiniz kapalı ama.
Sorry. Thank you, Meltem Yağcıoğlu, for her presentation. Are there any comments and questions for this presentation from another participants or listeners? Yes, thanks. In the last thank you. In the last presentation, we will hear about preventive methods and applications in flood control. Murat Sarıgül will present this presentation. He works as a training and technical support specialist at Proto-Altar. Sarıgül received his Bachelor of Science in Environmental Engineering in 2016 from Cumhuriyet University, Sivas, Turkey. He's still a Master of Science student on preventive methods and application in flood control at Yıldız Technical University Environmental Engineering Department. You can contact him by using his Gmail address. Yes.
Thank you, Professor Doğan-Sağlamtimur. I hope you are hearing me. Hello to everyone. First of all, before my presentation, I want to mention two things. Sorry about my background. I couldn't use a virtual background at my laptop because it's not compatible. Second one, I want to thank you to all science committee because they accepted me to here as a speaker. And also I want to thank Professor Türkdoğan for making this presentation possible. Let me just share my screen. Sorry. My topic is preventive methods and applications in flood control. Basically, I will get to the introduction slide, but I took a specific place from Validebağ, Üsküdar, Istanbul. There is maybe we are all, most of us are familiar with the Validebağ Woods because we know the place from Hababam Sınıfı movie. Çamlıca Fen High School is there. So it's a big area, nearly 100 hectares area, and the rainwater which comes to that area creates some flooding. This place is prone to flood frequently. So I took the existing rainwater infrastructure and somehow using some equipment, structures, and some softwares, try to rehabilitate and to design a new infrastructure rainwater system. If we want to continue with the introduction part, floods are one of the biggest disaster threats for the world we live in. They are not just for the small areas. Most of the world's places are having the flooding problem. Also, beside that, rapid increase of urbanization, which we are familiar here in Istanbul, and the change of climatic conditions and floods triggered by melting glaciers can cause great material damage. Our main objective of this study was to predict floods before they turn into disasters, which I said also with the support of software, which is capable of performing hydraulic calculations and simulations. If I have to say something more about floods, they affect the vital activities by damaging lands, settlements, some structures or infrastructure systems, and also living creatures, because floods can result in the death of the citizens. Floods caused by excessive regional precipitation and rapid melting of snow masses are the most common examples of flood events in many parts of the world. However, in the transformation of floods into disasters, besides of the excessive precipitation, there are some buildings which are built in the areas with flood risk. We saw these examples in Turkey mostly. Most of the flood examples happen when the buildings are constructed in the riverbed area. We can say two main causes of the flooding. One of is natural and the second one is artificial. Natural causes are excessive precipitation, rapid melting of snow and ice masses, and the last one is sea-centered earthquakes. They can also result in a flooding because of the tsunami waves, etc. And the artificial causes are urbanization, which, as I mentioned here, that we are familiar with the crowded cities. Some interventions to the riverbeds, and also faulty designs and interventions, which is maybe the bridge above the river is not done well, or the structure to prevent flooding in that river is not designed optimizedly. So when we get to the damages of flood, basically, the biggest impact is loss of life, while the result of material damage seriously affects the economies of the countries, and also it causes to socio-economic life to stop, because as a result of simple flood, 40% of the workplaces in the flooding region cannot return to businesses, and also for the citizens which live by the flooding, it's thought to be it may take more than 2 years to overcome the psychological effects of the flooding. Since the 1980s, with the rapid increase of urbanization, the flood-related burden has increased exponentially throughout the world. Every year, it's said that over 100 people die as a result of floods, and it's known that the flood-related economical loss in USA, for example, is about $8 billion for a year, while there is a loss of $40 billion a year in the whole world, when we think about the whole world. According to 2002 reports, the material damage caused by floods in Turkey on that year was averagely $100 million per year, while the amount allocated for control projects and studies to rehabilitate after flooding is $30 million a year. If you want to look at the material and methods I use in this study, I said I did use some softwares, CAD softwares also. Most of us, I think, we are familiar with the AutoCAD software. CAD means computer-aided design. So there are some CAD softwares called Urbano, Civil 3D, InfraWorks, River and Flood Analysis, and Storm and Sanitary Analysis. These two analysis add-ons are a part of the Civil 3D software. A part of the software side, I took some of the existing infrastructure system data and also the land data from the administrations such as Water and Sewage Administrations of Istanbul and DSI, which is State Hydraulic Works of the Turkey. They are both of them are responsible for the flood control in Turkey. These programs which I mentioned above is all of them are used for dimensioning the alignment of the infrastructure system. Some of them help to create a land model, to calculate excavations and field calculations. Besides that, most of time I used Urbano to calculate the flows and to make hydraulic analysis, and to get some of the parameters such as flow rates in the system, total flow data, cross-section field rate in the pipe diameter, etc. I want to give an example from one from Turkey and one of is from Europe. Maybe you all remember from Turkey. I experienced it also. There is this road. This picture is from the Basin Express road, which connects. Sorry about the resolution, by the way. This road connects two main arteries of Istanbul, which is E5 and Tem Highway, and you can see on the right side of the road, there is a small branch of the Ayamama River. I will get to the details of the Ayamama River, but there were two main floodings happened on the Ayamama stream, and it causes flooding on the Basin Express road. You see, the first picture is the two pictures are took from the Halkalı Bridge on the Basin Express road, and this one is looking up on the north side, and this one is looking towards the southern side, and you can see the buses and trucks nearly sank in the water. If we need to give some details about that, the average rainfall calculated for the September months in Istanbul is 45 kilograms per month. But the amount of the rain the city received in that 1 hour, one specific hour on that flooding day of 8th of September was recorded as 90 kilograms. Amoenum stream is 22 kilometers long. Sorry. It starts from the north side of the Istanbul, from Başakşehir to, and extends from the southern, most south point of the Istanbul, Bakırköy. And on that occasion in 2009, 31 people, the flooding resulted in 31 people dead, and above the more than the $100 million is calculated as a material damage. After that, it's 11 years and still the rehabilitation process is ongoing. It's still not finished. And there were some rehabilitations such as the riverbed section on the Basin Express part from the stream was increased from 9 meters to 30 meters. And also on the E5 highway route, the section was 12 meters. It was increased to 24 meters. I think there is one question. I need to check, Dr. Singh, I need to check my full paper. I think the data is from the United Nations report. I'm not sure, but I will check and let you know. The cost of, it's an average number, by the way. It's not an exact number, I can say that. The cost of rehabilitation projects is approximately about $30 million, but as I say, it's still ongoing process, and still there is too much cost. And the last one is water and sewage administrations and state hydraulic works administration in Turkey, which these are the two administrations which are responsible for the flood controls. Sorry. And after the example from Istanbul, I want to give you one example from the Europe. According to European Nations Development Program, between 1980 and 2000, it is reported that around 196 million people were exposed to flood disasters in more than 90 countries. In 2001, the German Ministry of Environment applied to the EU to implement the hydrostatics process under the name of Environmentally Optimized Rainwater Management System. And the pilot cities for that projects were Stuttgart and Stocka. The project almost entirely financed by the European Union, and after the pilot two cities, it was implemented also in the Feldkirch and Götzis cities of Austria. And also, I want to mention especially these two values. The conventional solution for that pilot cities to about the renovation of the existing rainwater infrastructure was calculated as just above 12 million euros. But I will mention in the next slides with the help of some equipment, some structures, innovative solutions, the total cost which was applied and projected and applied to these pilot cities were just 2 million euros, and there's approximately 83% saving in the meanings of cost. So what are those equipments? One of them is hydrobrake equipment. You can see on the top left picture. Hydrobrake equipment is not that big thing. You can see on the top right or bottom pictures. You can just put it in a rainwater system, one manhole, and you can just control the rainwater flow with the help of this hydrobrake equipment. You can see top right picture, there is no hydrobrake, and when rainwater comes from the high slope, here these buildings their first floors are under the water, but when we implement the hydrobrake equipments here, we can hold this rainwater here and we can control the flow that will goes after in the next pipes. And the second structure is detention pond structures. You can, if you have like in my example, because Valideba area is really steep area, it has a really big slope value. So the rainwater came from the basin area, quickly goes into the rainwater system and it causes flooding. But if you design and create according to some values that you get from analysis. You can, if you create this kind of structure, you can hold the rainwater in this detention pond, and you can discharge it to the rainwater system more optimizedly. And I want to mention some of the softwares just quickly. These are the softwares I use. I use Civil 3D. This is actually a video. You can see a riverbed here. I took point data from the Water and Sewage Administration and use it to create 3D land model. And you can see I can do some editing on the software, and it will give me some precise 3D model, and I can do some hydraulic analysis on the river stream. Also, I use Urbano. Urbano is used in the Istanbul Sewage and Water Administration by the Sewage and Water Administration. You can see we have some general rainwater station values in the program, such as Florya, Göztepe, Kartal, Sarıker, which is implemented in the software. And on the top, bottom left corner, you can see 3D pipes from the rainwater and sewage water systems. And also, with the help of the land data, I can see ground elevations and invert elevations in the 3D model. On the right side, top right and bottom right, we can see Grand Bazaar, and top right side, we can see Grand Bazaar's rainwater system, which is created by the Urbano. And third software I used was InfraWorks. I use this software to create a 3D model of the Validebağ Üsküdar area. You can open the map and you can select anywhere you want as a rectangular, and the software gives you coordinated and elevation, which includes the elevation data 3D model. And you can then, after that, you can do some kind of designs and analysis on this model. Last one, river and flood analysis. This is an add-on for the Civil 3D software. You can also, this is a video, you can define your branches for your river, and you can have some section cuts. Let me just go upon. You can have cross sections for any kind of any increments, and after that you can apply your manic roughness, or you can define your banks of the river, and after that it use HECRAS HECRAS analysis on the back side. And what we get at the end of the analysis, you can see when I click compute analysis, it started to analyze. And after the analysis, I can see all of my water levels in all cross sections. And after that, I can create my flood mapping, which is really helpful to see where will be flooding effects. Sorry. You see, I create my flood map now, and when I open the map in the Civil 3D, I can see which area is really under the water after the flooding. So this was the softwares, and last two slides. Sorry, if I use too much time. Sorry. These results are I need to mention. You can see bottom two pictures are from the Urbano software. The calculation formula was the same. The flow is calculated intensity multiplied with the runoff coefficient and from the selected area. The Göztepe station was selected, which was near the Üsküdar, and the inflow time for the rainwater was picked as 5 minutes. Total flow calculated for 15 out of 37 pipes were above the maximum flow capacity of these pipes. So there need to be some renovation. Also, I have to mention that the existing rainwater system in the Üsküdar is the system was projected and applied at least maybe 20 years ago, according to the ISKI data. So thinking about the system is that old. There was it was obvious that the system needs some upgrades. So I use Urbano Software's pipe optimization tool. I did gave the software some parameters, such as the water height in the pipe is selected maximally as 80%, and I selected concrete pipe catalog also, and I said minimum pipe diameter to be defined as 300 millimeters. And when you run the pipe optimization, you can see the left one, bottom left one is the existing infrastructure. On the bottom right one is the after the pipe optimization, which was done with Urbano. You can see the change of there were existing 300 millimeters pipe, but after the pipe optimization, the pipe diameter starts from the 400, and also 2200 millimeters pipes were 8 pieces, but after pipe optimization, there is just five pieces of 22 millimeters pipes. And this one is from the storm and sanitary analysis from Civil 3D's add-on, and it's my last slide for the results. You can see a short part of the profile view of the rainwater system from the Validebağ, because Validebağ rainwater infrastructure system is almost 200 meters long. And but here in profile we can see first and second manholes, and you can see the water that overflow from that manholes. And storm and sanitary analysis gives you the overflowing total volume of overflow, so you can design your detention pond or hydro break structure according to that overflowing rainwater. That was it. Thank you very much. Sorry, I was a bit, I think, long, but if you have any questions, I will be glad to answer.
Thank you. I realized a message from Dr. Ajay Singh to everyone. He said that you mentioned 100 leads per year. Mm-hmm. Could you please confirm if this data is for your country only?
No, actually, during the presentation, I already answered to Dr. Singh, I guess, if I'm not wrong. The 100 people number is not exact number. It's an average. It was my mistake. I didn't put here that it was average. And also, this was from the report that was created by the United Nations Development Program.
Mm-hmm. Is there any are there any questions or comments for this presenter? Thank you. In the last presenters mentioned about this stream basin located in Gebze, Turkey, and environmental experimental parameters like BOD, COD, nitrate, methane, and metals, and another one mentioned about flood. Flood is an important disaster for not only in places but also in every place in the world. And last presenter mentioned about flood control and models and technologies and methods like that. And then in the sixth session, we listen water and wastewater management presentations. We listen, 4 presentations about this, and I would like to announce you that 5th Eurasia Waste Management Symposium 2020 is finished today. Organization committee would like to see you next time in this conference series, because this is serious conference. In this year, 5th of them is organized organized by Turkish team via Zoom. Yes, I realized another message. Yes, Dr. Ajay Singh wrote to everyone, thank you everyone for this nice session, and he transferred his internet site to everyone. Yes, I would like to thank not only a presenter, but also audience and commenters. Thank you, everyone.
I want to also say something. Thank you for participation. Good afternoon, everyone, again.